All right, so Russell, thanks for coming in.
Absolutely.
Join us and help us understand things from your point of view a little bit better. So, if you would, start out by giving us some background on yourself.
My name is Russell Greenfield. I am the VDC, Virtual Design and Construction, and BIM, Building Information Modeling Manager for Fitzgerald Son's Plumbing Company, a commercial plumbing company in the greater metro Atlanta area. I've been with the company 17 years. I came up through the company as I came to the company as a master plumber, having worked my way through the industry from an apprentice. And in my time at Fitzgerald and Sons, I transitioned from working as a plumber in the field to a foreman to being a layout person for our large high-rise jobs to then transitioning into what was our burgeoning CAD department at the time, probably about 14 years ago now. And I have been doing CAD and computer modeling and coordination work ever since.
All right, good. So, what made you decide to go from field work to the CAD and BIM?
So I really had felt that I found my calling at the time in being a layout person. I really enjoyed going through the prints, looking at the structural drawings, the architectural. This was back before, we were just getting started in email in the field, and people, if you had a phone, had a BlackBerry to read your email on. Otherwise, we were all still running around with Nextels chirping at each other. And I had thought that I'd really found my calling as a layout person. I enjoyed doing the math, mapping out the walls, mapping out the beams, figuring out where everything was going to fall, and then going out onto a high rise and, getting with the surveyor on site and finding controls and laying everything out. And that felt so great to me. And then it was while I was doing that we were on a project, the first one I had been on, that was a prefabricated building in the sense that it was a large building, I believe a high school, and all of the architectural elements for the structure and exterior of the building were coming in on a truck, pre-built in sections. And the field personnel were taking maps and putting those pieces together, and the building was just coming together in big blocks. And I thought, that's amazing. And then I was on another job, not long after that, where our CAD department was really doing its first BIM coordination, and it was very new. We were all still working in AutoCAD at the time. I wasn't a part of the department, but I was out in the field, and they were sending me drawings and plans like, hey, we think it should lay out like this. And so I kind of just started following that, and I was marking the ceiling. Okay, well, they show hangers here, anchors here, and kind of mapped it all out. And at the same time, I was running into some problems and making changes as we went. And just in the course of that, I got a call from the person who was in charge of our CAD department at the time. And I said to him, hey man, anything I can do to make this work, let me know. Because I was at that last job and I saw that prefabricated building come in on trucks. I said, if they could do the building that way, all right, and the buildings are gonna be done that way, we could do the plumbing. Because the building's being built in a factory. They know where every single wall is. All right, there's no adjustments taking place. It is like this. And I said, if it's going to be like that, the plumbing could be like that. If they can promise us that the walls are going to land here, then we could build the plumbing and bring it in. I said, I believe in what you're doing. And if there's anything I can do to help make that work, let me know. And then it was probably just a few days later, I got a call from Richard Fitzgerald, who was the president of Fitzgerald and Sons Plumbing at the time. And he was like, I hear you're kind of interested in what we have going on here. He goes, why don't you come down, tomorrow afternoon and talk to me? And I did, and I told him the same thing. I believe in this process. I said, I think this is the future. I'm into it. And they said, all right. And they sent me actually to a quick 3-day course to learn, AutoCAD, which if anybody who's used AutoCAD knows in 3 days you learn to turn it on, and start a file. It was about it. And then from there on, it was trial by fire. And I've been doing modeling ever since. And now it's what I've done in the plumbing industry more than installing plumbing.
Man, that's exciting. What was it that made Fitzgerald decide to go that route? There was something had to happen to drive them towards that.
Yeah, Richard Fitzgerald he's alive. Richard Fitzgerald really was kind of like is like a thinker, and he's always looking at what the industry is doing, what's happening, where it's going, and he's always looking at companies that were bigger than us and doing things we weren't doing, and what are they doing and why are they doing that? And he somewhere met and started to communicate with a very large mechanical and steel contractor out of Colorado. And he said, "Hey, I think what you guys are doing is really interesting. Do you mind if I come out to Colorado, and have a look?" And so he did. And he went out there, and this company did all mechanical and the structural steel. So they really kind of had control over a lot of the building. And as such, they were modeling everything in-house, all the mechanical, the plumbing, where the conduit drops were going to be, and they were doing it all, and they had control over it. And then it was all going to their fabrication warehouse, and it was all being built right there on site and then shipped out in trucks. And he was like, this is the way things are going to be. This makes total sense. And he came back, and we had not long before moved from our old office to the other side of a lot where he had built a new building. All right, and our old office was sitting there, a 12,000 square foot facility. And he came back and he said, "You know what? This is going to be our fabrication shop." And they went in and they started ripping down firewalls, all right, and getting ready. And he went out and he took somebody who had an interest in doing this sort of thing, had a little bit of a background in CAD, and thought, yeah, this is great. This is a great idea. And they started a CAD department. They had 2 people. They had 2 computers and a desire to do this and a goal in mind, and they just went after it.
Cool. Were there GCs that were asking you to be able to build a project with BIM coordination at the time, or was it something that you approached them about?
No, there were GCs that were asking us. It started simple with, as-builts, things that made total sense for, a burgeoning CAD department, as-builts, small design builds. And then we got a contract to assist with an expansion of what we will call a large aquatic animal center in downtown Atlanta. And that they were going to coordinate. And they were only bringing people in who could coordinate. And we had all the tools, a little bit of experience, we were in the door, and then we were just off and going. And then since then, as coordination has become more and more and more prevalent in the field, we're just right there. I mean, that box is so easy for us to check. BIM job, great,
Yep.
We're on it.
When you get awarded a job, what do you see from the GC? Do they give you a set of drawings, or do they ask you to take this concept and run with it?
So it's gone both ways. Let's say that the job is we're contracted to do the coordination and the plumbing installation. It is not a design build. It is a classic contracted job. I will typically get brought in and say, "Hey, we got this job. It's going to be BIM." And I say, "Great. When's it start?" Because if you work in BIM, the more time you have, the better job you're going to do, because everything you do is planning and getting out in front and finding problems, and you need time to do that. So it's the first question out of my mouth: when's it start? Then we put it on the calendar, and then the next thing is, do we have backgrounds? For those who don't know, backgrounds would be files for, say, the architecture of the building, the structure in digital formats that we can see on the computer, something for us to look at. This is the building. And so then I'll immediately make a request out to the general contractor. Hey, we need backgrounds. I would like architectural, structural, and MEP design if you have it. And then I also say Revit files are preferable. If I can't have Revit files, 2D DWG is acceptable, but I want all of these. And then I produce a long list of plans, like I'm gonna need the architectural floor plan, the details, the plumbing overall, the plumbing details, a big long thing, which is a lot and cumbersome, and it's a lot easier if you can just get the Revit file, because then all your architecture is in one file, all your structures in one file, each MEP is in a file, and it all just comes together in Revit really seamlessly, and it's really a great workflow and a great workspace.
Mm-hmm. So it helps when you've already got a concept together for the other MEPs, so that you have a good idea of what's going to have to be in that space.
Mm-hmm. Yep. We will never trust an MEP design for the sake of coordination, because the other trades, just like ourselves, are going to coordinate, and the HVAC contractor is going to know HVAC doesn't work like this in that spot. We're going to have to change it. So we typically will use design files for reference. In the case of plumbing, we like to bring the design file in, and then we'll draw our own model right on top of it. And then if there's a question as we're looking at the plans, because no matter how good digital documents are in this day and age, the plans are still the contract obligation. So if there's ever a question of something on the plans that we're not certain about, we'll go to the 3D design model and be like, well, what did it look like when they modeled it? Like when they modeled something to make this plan, what did they do? And we'll go to that for clarification.
Mm-hmm. Yeah, that's, I think at some point the world will get caught up to the idea that, the digital model can actually represent the contract document, but if you don't do the exact step you just said, there could be whole bits of your plumbing system missing. There could be whole chunks of buildings that don't have structural to them when you start looking at the models, depending on how well that design team has done their work. And that varies tremendously by firm and by team as to how much was actually incorporated and if they even elevated anything within particularly MEP drawings. I mean, you could be looking at plumbing on the floor because it looks fine in plan.
Exactly right. I've never had somebody come to us with an issue that they wanted to resolve where one way or another we didn't look at a PDF or a paper plan to say this is what it's supposed to be.
Mm-hmm. Mm-hmm. Yeah, that's still this is what it's supposed to be.
Mm-hmm.
Even though we all know you sign the disclosures and all that stuff, like the example that always makes me laugh is like the civil plans. The guy laying out asphalt, there's not dimensions on the civil drawings. The curb and gutter is based on that CAD file. Like no one's pulling tape to lay out curb and gutter. And no one has in a very long time.
Right.
So it's like it's just a give and take in the reality that we're in. Like the reality is the buildings are based on the models because that's what the plans are based off of. There's a lot of scrubbing to make sure it actually works. And it goes back to those PDFs, but people are making shops and stuff just like yourself off of models that are based on PDFs.
Exactly. And it's interesting because you will find different, say, for example, different architectural firms, they're all making a model because that's how you make blueprints nowadays. But they all kind of have different ideas of why they're making the model. Some architectural firms will straight up tell you, we model what is necessary to produce a blueprint. Right. That's it. If we didn't need to model something in order to make it show up on this piece of paper, it's not in there. And if we could model something, say, across, let's say a building was split level, it had a step down halfway across the slab, like 4 feet. They'll say, well, we didn't need to step that slab down in our model 4 feet to make it look like on paper, so we didn't. So our slab is just all one plane, straight across.
With a line in it.
Mm-hmm. And then you have others that their model, someone there said, we are going to model what we are building, and this is going to be a reference when people wonder, well, what is that parapet going to do right here around the steel? They're going to go into this model, cut a section view, and see it. All right, it's going to be there. And so really, and you have to know which one you're working with.
Right. And I assume you guys like us kind of have a sense of, you're like, okay, it's this team, so we're going in with this setup because,
Exactly
historically
right.
speaking, this is, we're going to get a great model or we're going to get a not so great model. Then, I'm sure you guys are having to do a lot of vetting on your end too, outside of just the plumbing scope, to make sure that
Yes.
you're not putting plumbing in harm's way because someone didn't do their diligence to make the background work.
Right, exactly. Yeah. One example is structural footers. Structural footers, notoriously on projects that are on any side of sloped grade, step up and step down with the landscape to facilitate retaining walls, etc. But when you look at a plan and you're looking at structural footers, all you see is just flat footers with little symbols on them, saying that, drops down 1'6" here. You don't need to model that structural footer in 1'6" lower in a 3D environment to get that. You could just go flat and put the words 1'6" right here. So it's interesting. You do have to know who you're working with and what you're getting from them. And then at the same time, you have to kind of get a feel for what your client's intent is. What is their goal? Do they want you to come out, all right, with your robotic total station, okay, and set embeds, 1,000 embeds all the way across this thing and roll in with, a truck full of pipe and, tags and labels and iPads, and we can do that. And it's amazing. It's great. All right, I love seeing it. But sometimes you get a contractor that doesn't want that, per se, or that's unfair. Let me rephrase that. Sometimes you get a contractor that's not familiar with that. He hasn't seen it. All right. So you might be coming at them with a lot of questions about, hey, how are we going to do this? How are we going to build this problem? And you're kind of pushing them beyond what they're familiar with, which everybody knows anytime you're pushed outside your comfort zone a little bit, it is by its nature uncomfortable. We have done projects where we have been working with a contractor on a project, and it is a fully modeled job, BIM coordination, and we're going about it the way we know it needs to be done. And we're taking our model and we're sending it in real time to our field personnel. Everybody who works for us in the field can take out an iPad or a phone, pull up any single plan and the model on that device and look at it at any time. And our PM is in a meeting, and a GC, and he says, well, hey, we're doing this right here. This is the way we have it in the model. And a GC rep says, well, I can't see that model. And we're like, well, okay, we can. This is a BIM job. We do BIM. We're really good at it. So what can we do to help you? Like, how can we help you with this? Can we get you access to what we're looking at? Because the world is changing fast, and it's changing quickly. And there are people out there who are great general contractor superintendents who know how to build buildings. Like, they know the way it's going to go. They know how we're going to solve these problems, how we're going to plan for these contingencies. All right, they are masters of their craft. All right, at creating spaces and buildings, but they are not masters at navigating a 3D model, and that's understandable. It's really new. I mean, I remember I was in the industry. I recall making my bill of materials on a legal pad and then going into the GC's trailer and using his fax machine, all right, to send my bill of materials back to the office so that they could turn around and send it to the supply house. and that was how we conveyed information. And then I was around when email came along, and I remember working with some really great contractors who, some of them would have an assistant, and that assistant's job was to print emails and put them on his desk, all right, so he could read them, because this man knew how to build this building, and that building was going to get done. It was going to be great, and everybody was going to be happy. But email came along in his 50s, and he is busy building this building, all right, and we're going to figure out how to make it work for him. The industry just keeps rolling along, and it's going to do that for a long time. We're in a day and age of the human race where things move so quickly, and everything is just constantly getting faster, sharper, quicker.
It seems like it's exponentially.
Mm-hmm.
When we first started, I think it was 2009 when I first got here to Juneau, and I had a flip phone. Didn't have BlackBerry. Got a BlackBerry maybe 2 years later. And I remember I got a desktop, no laptop. Had to move it from job to job. And we had those superintendents. We still have a couple of them. But we've taught them how to use some technology to their advantage. I actually got one who hasn't written on a piece of paper in 5 years now. He only uses his iPad, takes all his notes and everything on the iPad, uses Procore well, and I finally got him over that hump. But from that point to what we're capable of doing now, it really is an exponential curve. And then what's coming in the future, I mean, we went to a conference in October last year, and I got to operate a robot dog with a 360 camera on it that's designed to walk around the job after everybody's gone, take pictures of the whole job, and then tell you what the productivity of that day was.
That's amazing, and also the amazing thing, was that conference in Las Vegas?
No, it was in New Orleans.
Okay, you went to the one in New Orleans.
Mm-hmm.
I was
The
like,
Procore one.
I've seen your
Yeah.
robot dog, and that made me wonder, were you there and we just missed each other in passing?
Yeah.
Yeah, I mean, and the concept of that a robot can walk up and down the stairs of your project, walk all around, avoid obstacles on the floor, and every single day give you a 3D environment of exactly what's going on is just amazing. And as a tool, both scary and awesome all at the same time. To be able to be in a meeting, all right, with your supers and say, what's going on over here, on the second floor of this wing, and be able to pull up what was recorded by that laser scan just 6 hours before. This is where we are right now, and look at it, in a collaborative environment right there in the trailer. That's an amazing tool.
It really is. What do you see that is going to be helping you and plumbing and what you do with plumbing and your design in the near future? Where do you think it's going?
I think where it's going, and some of it is out there now for the right people and the right projects, is even further into two spaces. The first space on our fabrication side would be furthering the elimination of human error by manual measuring, and paper. Oh God, I hate paper. Paper. Like, there is nothing that leads a project, all right, down the wrong road than one individual holding a sheet of paper saying, "Oh no, I have it right here." Hold up, buddy. What's the date on that page you're holding right there? Like, what's that from? We are modeling plumbing systems, and we are modeling them using for us in Revit, what are known as family objects. Basically, it's a model representation of anything that you need. You make a family object. So I need in the world of plumbing, let's say a 4-inch 90-degree bend. I have a family object that represents a 4-inch 90-degree bend. And that family object represents a 90-degree bend and it's dimensionally correct. So as we're modeling the plumbing, we know what every cut of pipe, all right, is going to be because it's right there in our model and the fittings are the right size and the pipe is represented correctly by the proper pipe that's going to be put in. And so now it needs to go to our fabrication shop and it needs to be cut. And so for me, where the next thing is going, and it's happening right now, will be from the model to a machine that cuts it. All right. Now, the HVAC side of our industry, they know exactly what this is because they've been doing it a long time. Things have been going from models to their CNC machines to cut ductwork. I mean, for really decades. You know, they are the true leaders in how virtual construction and fabrication really got its start, is the HVAC companies. And now I want to see the plumbing companies do the same thing. You know, I want to see a list of pipe cuts cut up and a robot stop on a saw. Just keep moving back and forth to the next cut and printing you that tag and sticking that tag on the piece of pipe and putting it on the rack, you know, and eliminating that tape measure. Take that tape measure out. You want to double check something, pull out your tape, double check it. But, you know, let's eliminate any stops along the way for this information where it can go wrong.
Mm-hmm.
All right, and let's go straight from one thing to another. I tell my department and the people I work with a lot, like, I don't want to be the middleman. I was like, I'm going to copy everybody on this email I'm writing because I don't want to be the middleman. I want you to know exactly what it is I'm saying, you know, and why we're doing it like this, you know, because in my experience, any stop along the way is a bottleneck. It's something where things go wrong. It's something where things slow down, and I don't want to see that. So for me, the next thing will be for plumbing, you know, the advancement of taking this amazing data that we have in the modeling process and pushing it out to fabrication, all right, for plumbing trades. The other side, which is also happening, will be how do we best get that data to our field personnel? Now, that has advanced by leaps and bounds in the last few years.
Yeah.
You know, I say I hate paper because I remember working on a project and it was change. The job was going to coordination, was still taking place. And I had to go out to that job at that time and run our total station. You know, we were in a spot, we needed an operator. You know, I went out, ran the total station on that job for a few weeks. And while I was out there, what I saw was happening is that the new plans, which had to be printed and delivered to the job site at the time on our truck, you know, there were plans everywhere. You know, there were changes coming out, you know, let's say on a weekly basis. And, you know, you started to worry, you know, the plans in this job box, how old are they? What's their revision? When are they from? Is somebody going to use these? Is this information right? And it was that experience that really led me to believe that actually paper is what is going to hold us back, all right? Because paper is a fixed point in time and it's not getting updated, but it is still there and it's hanging around. And, you know, I remember when you would go on a job to do plumbing and you would get 2 sets of plans. That was it. You got 2 sets of plans. Everybody on that job had to use that 2 sets of plans and everybody would run back to the plans. And at the same time, jobs didn't update like they do now. You know, when you got a set of plans, it was usually pretty good. All right, and you might use that set of plans for the entire project and get 1 revision throughout a project. But there were like 2 sets of plans. Everybody would run to those plans and check everything. But then when companies started doing coordination and making shop drawings, you're making your own shop drawings, and then you're making updates and you're printing more shop drawings and you're sending them out. And I could see it was stacking up. And I could see that at some point in the future, this was going to be an issue. This needed to be the thing that that we needed to give some focus to. Like, how do we eliminate paper? How do I make sure that when somebody's looking at a plan, they are looking at the correct plan, the latest plan, the plan we want them to see, and that everyone's seeing the same one.
And that's been the classic VDC bottleneck for the long time, right? And like until you said, until recently, is you have all this great work going on, not on the job site typically, with accurate information, and then what was the last set that job site had? Did they download the latest thing? You know,
Exactly.
like, and that was, we were inherently the middle people. We didn't want to be, but we became that because we had the most current information. The field team had maybe the least current information. So then you would get calls, you'd get like you were the one being hit up for, hey, what's this information that I need, you know, and that was just, it's not a sustainable way to live, you know, and thankfully the communication tools have come a long way, because that was the, you know, that was a challenge to get over, you
Right.
know, and it also infrastructure's improved enough too. I mean, cell connect, signal, you know, Wi-Fi ability, all that stuff was kind of coming out, or was involved in getting enough connection to a building that's being built, right? Like manufacturing's had a lot easier hand because they're staying in one place. Our world's moving. So how do you get Wi-Fi in a moving space? What's the cell signal like when you're on the 14th floor of 30? Like, you know, there's a lot of more inherent challenges of trying to, you know, take approaches from other industries that work, and then you're in a constantly shifting environment.
And it's been interesting to see the steps that have taken place. You know, we were part of a large scale remodel project for an international beverage producer in downtown Atlanta who was redoing some of their high rises. And you know, the solution that I saw at that time was that they loaded the plans onto a desktop computer. They put the desktop computer, all right, into a job box with a keyboard and a monitor in a what's the plan style job box, and they put it on the floor. And you know, you need to see the plans, go to that. And the GC took responsibility for making sure that the plans on that computer were up to date, and anybody could go and they could print up an 8.5 by 11, you know, right in that box, you know, of what they needed, you know, for the next few hours. And that was interesting. Like that was really eye-opening. Like, okay, so this is the first step. This is how we're getting it to the field. And it was a great test bed because, you know, it was a renovation of a high-rise, so the square footage was limited. You know, anybody could walk to that job box in a moment's notice and get what they needed from it. You know, and then to watch it go from there, exactly like you're saying, as connectivity has improved, and we no longer need the information up to date on a hard drive. We're pulling it right out of the cloud all the time. It's really, really interesting, and I love that I'm able to get data back and forth at that. But so to get back to your question, you know, where is it going? To me, the big thing I'm looking for next is how do we improve it even better? We've done great work. Procore has been awesome for us. We use Procore also. I like Procore. It is a great way to make sure everybody's looking at the latest plan. I like its model interface. The guys love it because it's like a video game. Like, I'm going through the model. You know, like they're playing Minecraft on their phone, and it's really been a solid step in the right direction for us. And for me, the thing that I think is going to be next is going to be some sort of augmented reality. I think in my mind it is similar to the product that Trimble created with Microsoft HoloLens, like, you know, where you're looking through a lens and you're seeing the model overlaid. And I actually love that product. We don't have one, we don't utilize one. It was just kind of a decision, like, is this the road I'm going to go down? Like, you know, I don't know that's there yet for us because of what we do. But I love that product because that product to me represents a crucial stepping stone. All right, that product represents the work taking place so that in the future our guys will put on safety glasses all right, that show them, all right, on and off with a switch, the finished product of the building as it's modeled.
And it removes the tape measure from the game then.
Yeah.
Yeah.
And it is, I agree with you. The HoloLens is definitely like the missing link. It's the desktop and the job box type of application. Is it super efficient now? No. Does it struggle to know where it is? Yes. Is it kind of clunky? Yes. But it's where we want to go, right? I agree with you. I think augmented reality for the field install side is the game changer piece of, all right, we modeled it correctly. We know where every bit of this building goes. Now just put the bit where the picture shows you to put it.
Right.
And I think you can take that even a step further with material that's stored on site and say, well, this is where you put it. This is how you go, just like the automated picking robots and, the enhanced human picking operations where it's like, it's in bin 6. This is the most efficient way to get here. This is how you avoid hitting the forklift. Go pick it and then come back this way and here you go. And if we could do that with rebar, how many tons of rebar would we save in the world?
Exactly right. We think about, we have all seen structural steel come in, and it's got white chalk on it. It's labeled with white chalk, and you go to the structural drawings, and you look up that beam. Okay, that's that beam. Goes there. And I think in this day and age of barcodes, and take me with a grain of salt because I have been locked, in an office doing modeling for a while, and I do not spend as much time in the field as I used to. But I think about structural steel coming off with barcodes on it, and people wearing safety glasses with the building and looking down, and your safety glasses just scan that barcode and boop, here, that's what this one is. And it's just all easily referenced right there, going back and forth with intuitive controls, and it's not there yet, or I should say it's not there yet for construction, but it's happening, and it's super exciting, and I'm really excited to see that piece of it continue to develop. As a commercial plumbing contractor, that's our niche. There are a lot of amazing tools that come out that I just want so badly, and I have to be like, realistically, this tool is amazing, but does it actually solve a problem for what we're doing right now? Is it making what we do better? There's a lot of tools that I see that, and Jake and I have discussed this before, that I think this is an amazing tool for a contractor. One we've discussed before is they make a robot now that rolls across the floor, painting whatever you want on your slab. All right, and
layout robots.
So
layout Roomba.
Yeah,
it looks like a layout Roomba.
That's fantastic.
It is, yeah, layout Roomba. That's a good way of putting it. So imagine at the end of the regular business day, when most of the field personnel go home and everything staged and the job boxes are closed, and then maybe you have one small team. All right, and they start this robot while the floor is empty and clean. And overnight, it rolls back and forth across your slab, and it paints every penetration, every core that needs to be made. All right, and I see that, and I think that's amazing technology. But that technology is amazing when it paints every core for everybody across the slab. Not just the plumbing. That is a general contractor tool. And I love general contractors, and you know what I love about general contractors? General contractors can make things happen through sheer force of will. All right? I have seen general contractors say, this is the way it's going to be. And everybody nods their head. All right, well, this is the guy who hired us. This is the way it's going to be. You are going to use this tool. You will use this website to do your punch lists. All right? Whatever it is, you will do it this way. All right? You were brought on because you said you could do it this way, and that is what we expect. And I love that about general contractors. General contractors can say, oh, no, we are going to BIM coordinate. You will model this. All right? And if you told us you could do it and you can't, guess what? You're going to figure it out. Okay? Because that was part of our contract. You're going to make this happen. And so I see things like that printing robot, and I think that's a general contractor tool, because a general contractor, the right general contractor, gets that robot, and he says to the subs, you will send us your penetration data. All right, you'll put it on this file format, you'll use this coordinated system, and you will send it to us, and you will have it to us by this day. All right, and you guys can make that happen. Like, general contractors can do that. And then it's all there, and that tool now, for the cost of that one tool, is benefiting everybody. All right, it's putting down that data for everybody at one time. It's doing the most efficient use of its time that it can do, and the best value for everybody on the project. And I see a lot of tools like that, and I think that tool's amazing. I was like, it's not amazing for us right now, but man, it would be amazing for a general contractor. Right. That's a general contractor tool right there.
I think there's so many tools, and it's a point we make a lot here too, that exactly what you just said, that like you have to make sure the tool works for you, because whether it's a scale thing, whether it's a project type thing, whether it's a risk-based decision, like you always have to, there's so many cool things, but it's like, is this actually working for what we have the actual, like what our actual challenge is? And I think that's an area now with the exponential growth, like we were talking about. You always have to evaluate tools that way, because you can definitely get caught up in the shiny thing that ends up costing way more money than you think it's going to, then actually doesn't work that well. Because you kind of have to, we can't, at least at this point, we're not replacing people in terms to some extent. So we have to make sure it works with how people flow and move and things. I think like, there's some stuff is just too, I can't really think of an example offhand, but sometimes things are just too robotizing, like it takes the craft or the soul or something out of it, where it just, you're not going to get people to buy into doing something like that. Kind of the classic example of trying to work multiple floors at a time. It's like inherently hard to get people to go up instead of going sideways, and you have to play within kind of, the parameters that we have or are willing to do as humans, because otherwise we just revolt, because that's what we're good at doing, right? and then we don't, we're not, the technology's not working for us. I think, a lot of it's now is figuring out how to enhance ourselves the best of our ability. Like, does a person need to walk a job every day to know where they are? No, there's robots that can do that. The layout's another good example with the right team and the right project of like, you can automate that, so it's finding those right pieces, and then you come up with going, yep, this is good enough. We're going to force everyone to do it. And then hopefully, people see the light.
And I think it's only fair in the theme of this podcast. You made me think about it. We've talked a little bit about layout. I've used the term robotic total station, and I think it should be recognized that for us at Fitzgerald and Sons, robotic total stations, all right, were game-changing investments. We purchased our first robotic total station from Trimble, and for those who don't know, a robotic total station is similar to a piece of survey equipment, all right? And once you set it up on a job site, it allows you to walk with a pole with a prism and a small, computer on it, and say, oh yeah, this 4-inch core goes right here. And then you just pick it up and walk to the next one, 3-inch right here. And what you're not doing is you're not pulling tape measures back to control lines and strings all the time. And you're setting up one tool, and that tool is eliminating thousands of tape measure pulls. All right, and it's doing it with greater accuracy, all right, because it is a machine laying out a dimension, all right? It is not reading a tape measure. It is doing what machines do. And we bought our first robotic total station. It was there before I joined the CAD department, because I remember when we bought it, I went and trained on it, and that was my path. I was going to be the total station operator. And then it was about the same time there, CAD department. You had to have a CAD department to run the total station. It was all happening at the same time. But when we went out to do a slab with it, after we really kind of wrapped our head around how this machine works, how to get the most out of it, and then started introducing it to superintendents, man, you can't get a superintendent to go out and dig an underground without hearing, when's the Trimble unit coming? When am I getting my robotic total station? Because the way it revolutionized, specifically for us at the time, how we put in underground piping was like the Wright brothers, coming off that hill. I mean, it was huge. What used to take, weeks accounted for in our estimates to put in underground, because you had to go out, you had to meet with the surveyor was going to give you some strings, you got some controls, you came out in the morning. You might come out in the morning to a job site and spend an hour setting up your strings. You had to do it. There was no other way, and it had to be right. You couldn't do anything that day that was productive without making sure that you set up strings so that you could pull tape measures from that string. And you needed two people, one to hold one end of the tape at the string and another to pull the other end. And you were pulling it constantly. All right, 2 directions each time for every single thing that went in the ground. And now all of a sudden there was one guy, and he's just walking down the ditch with a pole in his hand. He's saying, right here, right here, right here, right here. And he's dropping pins in the dirt. That was the first technological advancement that was just a huge dynamic shift for us. All right, was a robotic total station, our Trimble unit. And I think it's fair that it be mentioned, because it was big. And it's commonplace now. It's not everywhere. There's still jobs taking place without them, but I don't see a lot of jobs where it doesn't take place, and our jobs don't take place without it. I mean, our superintendents know what it can do, and they know that if that tool comes out here and we use it, we're going to get it right.
Mm-hmm. Well, that thing did 3 different things that everybody looks for. It made things correct. You're not worried about whether something is wrong. So the accuracy was there. Then it took away mistakes, like compounded errors, right? So that accuracy is just spot on. By making it that accurate, it made it fast. So there's less labor spent. So you're saving money. And by doing all 3, it made everybody's lives better. It wasn't just plumbing. It's the civil guy. It's our structural, our concrete, the layout for all of our architectural walls placement, for everything. We use those throughout the process.
Which is why it changed the burden before, right? Like previously, you could say, well, all right, what's the drawing say? Is it a layout error? Is it a drawing issue? If everything's laid out off robotic total stations or something similar, then it's like, okay, we know it shouldn't be a layout issue, it's a drawing issue. And now the burden, and why we do what we do with validating models and stuff, is because if the drawing's wrong, the building's wrong. Like, we've kind of, because people are so conditioned to take that, that information that's in that total station and go lay it out, we've lost the thinking. Like, if the thinking's not in the drawing, in the points put into the total station, then it's not going to be caught, most likely, by the person laying it out. So, like, we've just changed the burden to a different spot in the workflow, in a better spot in the workflow, but you have to make sure those dimensions are right. And the funny thing is, with all of this, with what I see anyways, the number one thing that we still deal with as we try to implement technology or anything is the dimensions have to be right. You can't, you don't have the time or the money or whatever to invest in, automated fabrication process if you're fighting dimensions constantly. Like, the number one thing to do in construction is get dimensions to work, whether that's a single plumbing discipline or, where the hold the ROs for the windows. Like, get dimensions right, then everyone has brain cells to solve something.
Yep.
And now that burden has fully shifted, I think, in most places to the VDC team that's helping to make sure those backgrounds are correct, because that's what everyone's relying on, and you need to have those accurate backgrounds, and I think that's that's still the Achilles heel of that stuff is it will be exactly in the incorrect spot.
It will be. And what's funny is we dig in, we get those backgrounds, And we do the legwork. We determine where's the best spot for this plumbing riser. Okay, where's the best spot for this riser to serve that fixture? Is it going to have carrier legs? Is it a security fixture? Like, what are all the things going into it? Where's the best spot to put this? And usually you have determined the best spot by putting it in what was not the best spot in a previous project and learning that lesson.
Mm-hmm.
And you're doing all these things, and you're using that model and aligning it to get it just right. And in the back of your mind, you're thinking, they wouldn't even give me this model until I signed the form that said we take no responsibility for this model.
Mm-hmm. Yeah, that's the catch-22 of technology and construction.
Love that little caveat.
And that's why, like, what we've started doing now is we, as Juno, we take responsibility for the CAD files. Like, when you ask for those designer files, those Revit files, we're going to give you our structural model that we've built from the PDFs and coordinated and validated, and then we're going to go through and scrub the architectural model, and we're going to give you, to the best of our ability, the clean models. And if we need to give someone CADs, we're going to give them the CADs. If it's CADs for structural or for like a formwork person or rebar or something like that, we're going to give them our structural CADs because we know that geometry is right. We've vetted it. We've put the effort in to go to 1/256th of an inch to model that stuff correctly, so we know it's right to give good geometry. And like, because if you pass down the design team models, more often than not, you can go, I mean, I'm sure you've seen this all the time, you could go pull the distance between two columns, and the drawing says it's 25/6, and it's actually 25/5 and 7/8.
Mm-hmm.
111, 120. I mean, it could be anything from basically there to, I mean, I've seen it be almost an inch off because they had a rounding tolerances set to an inch. I mean, it's wild what it could be. So, you have to, that's where we're like, all right, this process works, then we have to take responsibility as the contractor to give good information out, because you can say the design team technically owes us that, and to me, dimensions are never a means and methods discussion, right? Like, you're responsible for code, you're responsible for calcs. Code and calcs are built around dimensions, but at a certain point, a 1/4 inch becomes our problem to solve and to make sure it's there. But oftentimes it's quite bigger than that.
Oh yeah. A 1/4 inch to a Trimble unit is a glaring failure.
Yeah.
And I love that y'all are doing that, and I'm seeing more of that, and I really like it because it's like you're saying, when you're creating that model, your mindset is, we are creating a model that represents this building, and the PDFs are what is going to be built. So I love that, and I'm seeing more of it. I got a few projects going on right now that have contractor created models, and I really enjoy them because you don't have a lot of that uncertainty. Like, just like you're saying, like, we are taking responsibility. Maybe this model doesn't have every nut and bolt and detail, but that wall is where it is supposed to be, and it is the right size.
Because models are kind of perfectionism in a way. Like, there is not really errors in models unless you've just allowed it to be there. Like, the built environment will always have air in it, at least for the immediate future, right?
Mm-hmm.
Like, things are plus or minus a quarter, and that's just what it is. But if we start with plus or minus a quarter, then we get plus or minus a half, and it just keeps trickling.
Yeah.
So, I mean, to me, it's like that's your chance at perfection in the built environment is models. You can put it exactly where it should be, and then, you give the field team the best chance to get it as close as they possibly can to where it should be.
I recall being our total station operator, and control lines were put down on a slab, 2-3 story medical facility. And I went out and I shot the controls with our Trimble unit, and I was like, okay, well, I got a 1/2 inch bust. All right, not the end of the world from one side of the building to another, but still, to a Trimble unit, a 1/2 inch is the whole world. Like, you have messed up. You are a 1/2 inch off. Total fail. And so then I went in my bag and we grabbed a 100-foot tape measure, and we measured the steel. We pulled the steel from one end to the other. And I was like, I remember going into a contractor's trailer, All right, just some dude working for a plumbing company on the Trimble unit, and saying, "Hey, the building's off. The steel the steel from one end of the building, all right, is about 3/8 of an inch too close together." I was like, "What are you gonna do?"
And what did he say?
He just about threw me out of that trailer.
3/8 of an inch? I don't think so.
And I learned an important lesson that day. The point you're making, that when a model is perfect, and when we're putting it together, we're doing the best we can. And the buildings being put together today using these tools are so much more accurate than they used to be. I mean, projects that used to have multi-inch busts and floors and like 3 to 4 degree rotation as the floors came up. But that was a very good learning experience for me that day, both in humility and how does all this actually come together and work.
How accurate does it actually have to be?
Yeah, that's to me the art of a great superintendent, is they can take this 1/256 accuracy of the model and then relate that back to the plus or minus a half that may be going on easily in your concrete high rise, right? And get it all to work and appease everyone and put it in just because there is inaccuracy in all of it, but you just kind of have to be able to roll with it and make the right judgment calls along the way. And because you can't, it's not realistic to as-built that and go, well, this floor is off this way, so I'm going to slightly make this column crooked, then I'm going to go do this and that. Like, Revit works in a perfect world. We're going to draw a perfect world. You guys have to interpret the imperfections that have been created, and how is that going to, how is that actually going to go together?
Well, I don't want to discourage people from not going to the GC and saying, hey, you're 3/8 of an inch off. But it is information that we need to know, because if it's 3/8 of an inch off on this floor and you go another 3/8 in the same direction on the next floor, and that compounded mistake, by the time you get to the top, you're an inch or two off. And knowing that, you can account for it in the next area. So you still need to know the information, but it's how you handle it from there.
Absolutely. If you're doing a building, like the one we're in, a multi-story glass-sided building, that glass is being fabricated at the same time that you're putting up the steel, or even worse, probably more accurately, a formed concrete. All right, formed concrete, boards are being built, it's all being measured out. There's total stations and tape measures and plywood flying everywhere. And, meanwhile, glass panels and framing are being built to go up to the side of the building on the idea that the inserts, all right, that they're going to connect to are going to be just right. And if you're compounding a quarter inch, if your building's tall enough, all of a sudden now your glass doesn't work, doesn't fit.
And we have to guarantee those openings. That's something that we have to do to release that glass to be made in time. You have to guarantee those openings are going to be right. And if they're not, you got to pay for it.
I mean, field measuring is done. That I recall that happening in my lifetime. But it's no longer. I mean, there's very few things that ever get field measured anymore in the world, right? Like, exactly where that stuff's supposed to be. You tell them this is where it's going to be, and our job is to make it work out there. If that's bushing this, taking off this piece of Den's glass here, putting on a piece of Lamy metal, and then waterproofing that. I mean, all the kinds of tricks of the trade to make up what it needs to be, because we're going off of what it ought to be, not what it actually is.
Well, we got to make sure that we do our QC behind the guys, make sure that they are putting it in the way the drawings show. Because even if you have a Trimble, the HVAC guy may not, and he may put something in that isn't 100% correct, and you've got to catch that before you do cover up. And the fire sprinkler guy and everybody else that's involved with the coordination effort, you'll figure out who your weakest link is during that process, and then especially after cover up.
I used to think it was interesting. We would be a plumbing contractor out there with a robotic total station, and we would be laying out, and man, we would be laying out with certainty. All right. And then a framing contractor would come along, and they'd start pulling their tape measures and laying down strings for walls. And, hey, man, you missed the wall. I'd be like, prove it. Because I'll prove to you I didn't miss the wall. All right. And that was really a big thing when we started to be able to be confident in that. Are we right 100% of the time? Nobody's right 100% of the time. I will say this. Normally, if you have something that was laid out by a total station and it's off, it's not off a little bit. All right. It's off a lot. It's off visually a lot. Like, people call me, they're like, hey, we're like a half inch off. I was like, are you sure? Like, half inch off sounds like a human error kind of thing to me. Like, if you'd called me and said we missed by 3 feet, I'd be like, oh, man, maybe that is us. We should check that. But like half inch sounds like, go find the guy that laid out that wall. Get with him. You figure out where that half inch went.
Yeah.
Because the machine didn't eat it.
Yeah. Concrete guys, they're great at keeping things accurate, right? Those forms always stay where they're supposed
Perfect,
to.
right? Sure, a footer has never been overpoured in the history of construction.
Never.
because your excavator dug 3 inches too far, and the truth of the matter was it was cheaper to pour concrete in that 3 inches than it was to
Backfill it and redig it
and form it.
Yep. Certainly is.
That's interesting. We have a series of standard operating procedures and how we do. One of them I will share is we have a 2-foot buffer zone around all underground concrete. If there is a footer, the plumbing stays 2 feet away. All right, we're not going to go closer to that on underground concrete unless that plumbing has a riser right there, and that's just where we need to be, because if they cannot be trusted. Footers are weird animals, and they grow and they change and they morph, and just give them the space they need to do what they're going to do.
Yeah, that's accurate. All right, well, I appreciate you coming in and talking to us. This is a great conversation. A lot to look forward to in the coming years, see where technology takes us.
Oh, yeah. I mean, the way things are going, we'd be able to repeat a conversation like this, every year or so, and every year it would be different and new. I mean, we're moving at that speed now as an industry. It's really amazing.
Yep.
Yeah, agree.
Thank you for having me. This was a true pleasure. I've never done a podcast before, man. I'm glad this was my first.
First time for everything.
That's right.
All right.
Happy to have you.
Thank you.